Yug Ajmera for this podcast. It's not a kind of a podcast where I really focus on robotics or neither about the rods. I always have this one motto of getting what an approach can be and what should be the thought process. So now I have a robotic enthusiast called as Yug Ajmera, an amazing guy. I think probably when you just look at the podcast, yep, you can really say that there's a lot of things that you can learn about him and the approaches which he has given. You, Gajmira, for this podcast. And you, Gajmira, I would love you to give a short intro of yourself for this podcast.
Guys, I am Yug Ajmera. I am a final year mechanical engineering student at BITS Pilani, Hyderabad Campus. I am incredibly passionate about building robots and intelligent agents that move and interact with the world in
You
useful
have been a
ways.
robotist for quite a long time now. As an enthusiast in the community, yes, it's a way more big thing. I just want to ask you this one question. We have been told microprocessor is the brain of the computing system, right? I just want you to ask that one view on the difference between processor, brain, and a robot, according to you.
Okay, so if you see, our brain is much more advanced than the current processors, but like we are trying obviously to get some computation done on the processor, and robot is something like a we can say a microprocessor is a brain of a robot. So the computations are done on the processor, but you still need sensors to sense everything, to sense the environment and all, and you still need actuators to do some kind of a work.
Okay, you told about the actuator because you're an intern in the Lincoln University now,
Yeah.
working remotely, that's a pretty big team. There is new ways in which technology has really disrupted the market. Robotics came in, there was a new way of disruption. Can a processor or a microcontroller be the brain? Literally brain. That's what I'm asking you all about. It can be a new thing, but yet it's your view. I'm just asking for it.
Yeah, so it's a far-fetched thing to comment on, but yeah, in a decade or so, we can achieve uh, somewhat closer to a human intelligence, obviously.
you know quite while I uh, just learned about ask you this one question. As an intern, you have actually came out with a new journey in your robotics enthusiasm. As an enthusiast in the community, you have come up with a long way ahead. Next year 2021 June, we'll all be graduating and going out.
Yeah.
But I just want to ask you this one question, like, do you still remember your first piece of code which you just worked on?
Yes. So uh, I know a couple of people who are doing robotics since high school, but I was not one of them. My journey of robotics started in my freshman year when we had a line follower workshop arranged by the seniors of my college. So we have a club called Automation and Robotics Club. So they were arranging this line follower workshop, and none of my friends were getting enrolled in the workshop. But I don't know, there was some inclination that like I should be like exploring new things. Now I'm in my college and all, so I enrolled, and then like I was at the end of the workshop, I was the first person whose robot had completed the whole like following the whole line. So I was the first person among 200 plus teams, and that was the kick which I wanted. And at that time I knew that yeah, I what I want to do in life is robotics. So yeah, so my first robot was a small tiny line follower robot, and I wrote the code on Arduino.
Oh, okay. That too was also my first robot, which I actually built in my freshman year. As soon as I went to the college, first week I actually never got any sort of workshop, so I did a line follower board. That's what I also did.
Okay. I
That's
think
actually
every
every
roboticist
person.
starts with a line follower and then goes on.
Yeah, now the era is in such a way that okay, microcontroller, if microcontroller is not available, just transform the driver into a microcontroller just with
Yeah.
some logics, that's it. You don't have
Hmm.
to really write the program, that's what I did. I just saw some YouTube video and I started doing it. Yeah, that's also gives me a lot of kick of doing that process of learning
Yeah.
what robotics was all about. Uh, you told about Arduino. I actually was thinking about this one question. How has computer changed the way in which robotics has to work today? The process in which robotics are getting built, or the anything. How has it been an influence in the field of robotics?
Like it's a major transformation. If you see Boston Dynamics Atlas, you can't really think of using an Arduino for the this big robot, right? So you need high speed computers and all to get the computing done for the robot to sense the environment as soon as possible and get things done and react to
That's
it.
a pretty good way of answering it, because not all people think about this reaction, about how the robot can react to the present situation. I always had this one question, can we really simulate human touch tomorrow from an robot? From a robot,
Yeah. Yeah. As a matter of fact, uh, next semester I will be doing my thesis in TU Darmstadt, Germany, with Professor Jan Peters on uh, learning human robot handshaking behaviors. So we are trying to achieve handshaking uh, through a robot, which is as close to a human as possible. So if you are handshaking with a human and then the robot, you can't really differentiate which is what. So we are actually bringing handshaking closer to what actual human touch is. So yeah, we can actually think of simulating human touch in the near future.
yeah, simulating your human touch is fine. Computers are used in simulation somehow, or the materials will be available. Actuators are
Yeah,
more into kind of getting humane. People are using materials which can behave very close to a human being, but not that close, but yet we will go to that age quite early. But I always had this one question. You have been writing a lot of blogs on ROS. I just saw your blogs and it's pretty cool
yeah.
that you are writing blogs on ROS. That's actually pretty amazing. Where actually putting forth your understanding of what the subject is in a form of blog. Amazing it is. I i always had this question: what will a robotist think about parallelism, and how has Ross really influenced the robotics in terms of computing today? That's my question.
Yeah, so ROS is basically a meta operating system. So what it basically does is you don't have to write all the code. You can just use the previous version of somebody's code, extend it somehow, and then use it on your robot. So say you want a autonomous mobile robot. So you don't have to actually write the A star algorithm and the X star algorithm. If you know how it works, that's good. You just use ROS on your robot, and then you use the pre-built packages or libraries, import them, and directly work on the uh, work on the previous code. Like the quote on the Google Scholar says, like work on the shoulders of a giant. Like you continue some other people's work to and modify it somehow so that you are improving their work as well as you are fulfilling an application for which you need the robot for.
Yeah, you told about fulfilling the application and everything. That actually gives a little bit of insights, but I actually require this insight from this question. I don't know how you can answer it, but yes, I just want to ask you this one question: what is Ross according to you?
Okay, so according to me, ROS is the easiest tool in robotics for various reasons. First and foremost, it's very easy to use. Second, like it has an infinite number of applications, from robotic grasping, from navigation, from machine learning, from artificial intelligence. You can integrate OpenAI Gym with ROS, and again you can do a lot of stuff. But for me, why ROS is important? Because uh, we are undergraduates, we don't have funding, and sometimes we cannot get big robots which are very expensive, like Boston Dynamics Atlas or Spot Mini or a normal robot locomotor or a manipulator. You just don't want to waste your time building those. You just want to buy them in the industrial, like in the industrial manipulators and stuff, and then work on them. So if you need them, or if you don't want to put in the cost of buying a robot, you can easily simulate them like they are in real life on Gazebo, and then apply your software, apply your code on them, and see if it works or not. Yeah. So
Yeah, I know you told everything about Ross. That's actually in a simple way. That's actually pretty cool, man, because not everybody has this kind of understanding to, we are all in undergrads. Not everybody
yeah.
gives this thought process of understanding what it can be also. I
Mhm.
always had this one question, like, it's a pretty cool way that you have answered all these questions, but I always had this one question of asking you, what's the thrill in doing robotics? There are a lot of subjects which are involved here. There are a lot of things going on behind one
Mhm.
system. There is an humongous way of testing, extended integrated testing, everything comes, which is used in software domain, but yet in a hardware domain. What's the actual thrill in doing the robotics?
Yeah, so as I previously said, when your code comes to life, like when you write the code, you can't really see something working. But then if you apply that code on a robot, and then if it works, that's the thrill in robotics, which like is enthralling and exhilarating. And uh, one thing what I remember from my experience is, in my first year I was making a small humanoid robot, and I had spent like hours and hours of work writing a code, but just thinking how it will work. But when that code actually worked on the robot and I could see the biped robot walking, that that's the thrill I work for.
Yeah, I know. That's what we actually really work for. We actually will be very happy with little bit of changes which we see with what we
Yeah.
build also, because learning process, yes, it's so hectic that we will be having our assignments, we'll be having our academic things going on in the back, but getting the robot do something, that's a pretty cool way of doing it. No, actually it actually gives the thrill. You don't have to even build the entire atlas bot or anything. Even if you
Yeah,
just build,
you can just build a part of it and then
it's
see it
actually
work.
enough for us. It's actually enough for us. I actually wanted to ask this question to all the robotics, because prosthetics are now in demand. There are a lot and lot of ways in which not just human actuation is getting simulated, but there are a lot of ways in which actuations are trying to build an actual human. There are robots which actually are made similar to a human being, where they cry, they
Mhm.
laugh, they do everything. uh, what do you feel about the actuators these days?
So, uh, as far as I have understood your question, uh, you see, actuators are like, as we talked about, like as our talk we before, uh, we are trying to achieve uh, the human touch, or something that's very close to human, as you said, crying, laughing, etc., the human emotions. And I think actuators are going towards human intelligence, or you can say, you can call it a human robot interaction, where the robot is actually behaving as close to other human.
Yeah, I think you summed it up somehow to say how an actuation is actually working for in the present world. uh, there are a lot of ways in which uh, data science is in picture in robotics. Every move of an actuation or every command which you give, it's all from a global command, all different actuators working together, everything is another. It's also a data today, how much voltage is going on, how much current is going on. There's a lot of things which is happening. I just want, because you are a mechanical student who has a minors in data science, and also
Yeah.
now interning outside through and remotely, it's a pretty hectic thing, because nobody has that will to do anything remote, because
Hmm.
everything has to be in a form of physical touch, because we as a human have been there. I just want to ask you this one question: how much is the influence of mechanics in robotics? I know there's a pretty huge, but according to you, what's the influence of robotics with the
Yeah. So
mechanics?
So robotics is a what I feel. Robotics is a combination of three fields: the mechanical aspect, the electrical aspect, and the software. The software includes machine learning and artificial intelligence, and writing the code and all. The electrical part involves the things you said, voltage, current, and all. And the mechanical aspect, now this has two things. First, simulating the robot as per your needs, or second is the kinematics and dynamics of robots. So if you're working with a robot manipulator, you have to know how the robot will move in a three-dimensional space, right? So you have to know the kinematics and dynamics of the robot in order to make it move to a point A to point B.
Yeah, I know you told about the kinematics part, and everything is in line, because
Yeah,
if probably if somebody sees this podcast and says, okay, I'm listening to a lecture which is organized, kind of, because yes, we know you are very clear with your questions. I gave you some draft questions, you never said that you are not going to answer that, because I have not worked on it. That's
yeah.
actually absolutely cool, because nobody has that will to say that, I don't know, I don't. That's it. Actually, why I told you this was, there is a lot of ways in which people fall in the pit with their ego problem. There is a lot of
Yeah.
ways which ego really hurts. I just want to ask you this one question of, what's your approach in building a team, a robot? How are they different, or else are they really the same?
So a team of robots
A team of
versus one
robots
robot.
and a teammates to build a robotics team.
Okay, so
Yeah,
yeah.
it can be of anything. Team of robots, teammates, and a robot. What's your approach in it?
So, firstly, for teammates, like working in a team, so I served as a software lead for Hyperloop India. So, I had 15 teammates working with me uh, for building the software of the Hyperloop pod. And the software is a very major aspect of the pod, because if it fails, you cannot control the brakes, you cannot control the actuation, and it goes on. So, uh, what I feel is giving everyone a voice while discussing the ideas is a very important thing, and you cannot let even a single idea go in vain. You have to respect everyone's idea, even if you know it will not work in the future. You have to respect them. You have to go in down the line and then show them that why it will not work. Now, coming to a team of robots, which we call swarms. So, uh, communication between the swarms of the robot, like the individual robot, is very important. And I think everyone in the field of research, where they're researching in swarm robotics, everyone is hindered by only one single problem, which is a major problem, that is the communication between the robots and how to organize the swarm. So if you have applications where you need multiple robots, like search and rescue missions, where you actually need a swarm of drones, then I think a swarm is necessary. But for minor applications where only single robots are enough, I don't think you need a swarm of robots for that.
Yeah, when you told about the requirements which you are supposed to jot down before you actually
Yeah.
build a project, that actually gives me a lot of insights on how you have really worked. That's actually cool, because nobody has this guts of asking everybody a question, and giving them a chance that okay, your idea might be good, but let's just also work on this, because that's how, team management is something which our generation lacks. Yes, I can be very confident about it. Team management, no way. We lack at it sometimes. When you told about that, nature is always there, whether it's swarm robotics or else an individual robot,
Yeah.
which is actually a pod or a bot, anything is fine. I always had this question, where is robotics getting influential in understanding the human nature and also the brain? Blue brain project, everything. There's a lot of things going on all of the sudden. Robots are involved there. What's your view in understanding all these phenomena in which nature is getting involved?
Okay. So if you have seen TEDx talks of professors in robotics, you would have seen swarms of fireflies, which are drones, but they call them fireflies. Then there are drones which act according to human gestures. So if you wave your hand, it will go away. If you do the sign, it will come back to you and all. Then you have Spot Mini, which is a dog robot, and there are a couple of researchers who are working on snake robots, which are very easy to go in small holes and stuff. So yeah, we are actually getting influenced by nature a lot. And like coming to drones, we are learning how to purge the drone on walls and all. So there is a lot of research which have involved robots that are highly influenced by nature, and we are still learning how nature has created animals and birds and insects from which we can get influence, from which we can learn how dynamics and kinematics actually work, and how we can uh, like reduce the cost as much as possible to fulfill our needs.
All about needs is not we are actually working, but yet we are actually trying to go step by step, inch by inch with a new solution. Step by step, it's a new
Yeah.
transformation altogether. I always had this one question of like, uh, is there any experience where you actually thought to yourself, okay, this should have had happened in 5 minutes, but it took me a long time? Is there any experience like that? And also, can you give an experience of working with the best application of ROS?
Okay, so the answer to your first question was when I was building my second drone. So I had previously built a quad rotor, and I was moving on to building a hexa rotor. And I thought that I already have an experience building drones. So I think I will easily make the hexa rotor in a very small amount of time. But moving from a quad to a hexa actually took a lot of my time. Firstly, because scaling, when you scale drones, you have a number of things to keep in mind, be it the thrust to weight ratio, be it the battery, uh, like everything. So yeah, making a hexa rotor from a quad rotor experience was something like which I thought would take very small time, but it it was a whole lot of good experience. The answer to your second question, what was the second question?
Sorry. Yeah, the second question was, what's your best experience in working with the best ROS application?
Okay, so I did an internship at Vinan Labs. So there we are actually building a robot for hospital sterilization. So we were aiming to build an autonomous robot. So you just keep it in a room, closed room. It will autonomously move and sterilize the room and then come back. So that was a pretty difficult task, because autonomously mapping the room, then navigating and making sure that every corner of the room is covered. We had a UV radiation tubes on the robot, so we just have to make sure that the robot goes to every inch of the corner and then come back. And speaking of hospitals, so it's a very critical uh, environment. So there we like we were trying to use a multiple approaches, but then at the end ROS was our only rescue. We used the ROS navigation stack, which is very easy to use, and like it's very easily configurable to your own needs. So yeah, for me, the best application of ROS for my journey was the navigation stack which it provides.
Yeah, navigation stack is something pretty cool. Not like that simple set of code is actually doing a lot of things.
Yeah.
Companies like Uber, Lyft, everybody uses S2 geometry for that. And actually ROS actually gave us the pretty cool way of actually having that navigation thing faster. You can just download it, somehow get that code, or somehow just implement it on the processor which you're
Yes.
working, and everything goes fine. That's where everything comes into the picture. But now the question is like, there is data fusion, sensor fusion, sparsity involved in your machine learning models, which let it be for navigation of the system, everything. Do you really feel that we are just building algorithms because of the set of hardware which is available? Also, is the hardware still compatible to the architecture which is there? What do you feel about it?
Okay. So what I feel about it is, if you see particular algorithms in machine learning or artificial intelligence or computer vision do need uh, some computation power for your hardware. So it has some hardware constraints. All algorithms has hardware constraints, right? But then computer vision algorithms and machine learning algorithms are a bit uh, like they do require much more hardware constraints. Like you need a GPU for training, you need a good CPU and all. So and we are actually making hardwares that fulfill these demands. Like if you see Intel Jetson Nano, they primarily build that uh, device or the hardware for running computer vision or machine learning algorithms. So yeah, we are moving towards fulfilling the needs of data science.
Last question. Let's just not actually go too much on ROS or anything, because yes, you have a lot of experience. Yes, people can reach out to you at any given point and get your experience, also get your
Yeah.
thought process and actually solving that problem statement which they are stuck with. That can
Hmm.
really happen. I'll post everything in the description below so that they can
Hmm.
reach out to you at any platform which you have. I always had this question: will robotics for babies be an reality?
I think so. Uh,
Neural network for babies is there. That actually meme is coming out, everything is happening. But yep, I just want your view on whether the robotics can really happen.
Yeah, like I think so. It can happen, but like not for very small babies, but for if you see, there is a Jibo robot which interacts with kids, and like there are a couple of robots which interact with kids and give them learning of some kind. So yeah, I completely feel robotics for babies will will go forward to some point, but it has its own constraints. Like you cannot give the robot freedom to move around and go, and you cannot give robots some any kind of freedom around babies. But yeah, if it's a stable robot, if it's giving some kind of learning, then you're good to go.
Yeah, because a lot of people have this one question like where to start learning robotics from, and also how to approach it. And can you point out to some resources in a quick span of time?
Yeah, yeah, sure. So okay, how I started robotics is gaining hands-on experience. If you like, you
Everybody
have
needs
to.
to have that.
Yeah, but yeah, if you are working in data science field, you just I like people you will hear people say that you need to learn these algorithms, data structure and algorithms and all. But for robotics, all you need is some enthusiasm and some hardware and the sensors and all. all of that, that's all. You just have to combine everything. There's YouTube tutorials, there's a lot of YouTube channels which are actually working towards teaching
Any
robotics
specific
very
ones?
easily. Not uh, I can't remember any of them. Like they were the ones which I uh, used to watch in my first year, all related to Arduino and all. So what I will say is first start with Arduino, learn how sensors work, how actuators are given commands and all. Then move to Raspberry or Jetson Nano, and then move to ROS. And in ROS there are various resources. I get a lot of question on how to start with ROS. What I would say is there is a YouTube channel for ROS just called Deconstruct, which has playlist on ROS basics, then ROS manipulation, ROS navigation, and all you need to do is just watch them and follow them on your laptop. You have simulations on ROS. You just have to follow them. They will give you an hands-on experience. So everything boils down on to getting a hands-on experience. You don't have to learn everything or mug up everything. You don't have to do all that. Just take a robot and work on it, see how it works, see how you can apply it to the real world problems. Or you can do top to down approach. You can think of a problem and then think of what kind of a robot would solve this problem.
To Yug Ajmera for this amazing podcast. It actually gives a lot of insights on your hustle, which you have literally put in order to gain the knowledge of being a proper roboticist in the community. Community actually wins over whether you are the greatest, whether you are the
Yeah.
best, but yet community has to work on. And thank you so much for it.